Is the Algebra 3 Test 14 review part 2. Picking up with question number 11. Let's pull this up. Might still be up here. It's not. Get this password. Find 14 review. Image. Whoa, too close. Back it up. All right. Question number 12. Seth went to the music store because they were selling P tapes for C cents. Don't take that literally. Okay? When he arrived, the store announced a special of 10 cents less on each tape. How many tapes could Seth buy for $6? Seems somewhat unfair since those $6 are the only thing that's really being considered as actual numbers. All right. So let's see. Out of this, what do we have? We've got tapes. So we're still kind of using distance, rate, and time, even though distance isn't distance, and our rate is still rate, and our time is not really time in this sense. But our rate, as all things considered here, they're selling P tapes for C cents. But you're not going to buy multiple tapes per cent. You're going to buy cents per. It's going to be cents per tape, right? Does that make sense? Okay. No pun intended there. So rate is C over P. Okay, we follow that? Yeah. All right. So, and they are, they are on sale. So they're actually cutting off 10 cents per tape. Is that right? Yeah. Okay. So really what we have is minus 10 cents per tape. Essentially minus 10 cents per tape. Okay? So it's going to end up being C minus 10P over P. Does that make sense? Okay? So that is our new rate. Okay? So our new rate, better yet, is C minus 10P over P. Okay? And so if we want to know, essentially we're calling it time. If we want to know how many of these we can buy for $6, we're going to multiply by the reciprocal. But because it's in cents, because this is in cents, 10 cents, I'm going to change $6 to 600 cents. Okay? And we're going to multiply that by the reciprocal. So what I'm going to get is 600p over C minus 10p. Try to get this guy right up there. Right there. All right, 600p over C minus 10p. Any questions about that? No? Biggest deal is trying to get that rate right and then get the change in it correct. Okay. All right, 13, write the equation of the following sinusoid. Okay, 13. What is my center line? -3. Good. All right. What is my amplitude?
1. Or is it 2? 4.
It's actually, because we're going from -3 down to 7, it is what? -4. Okay. And because it wants, it's just asking for the function of the sinusoid. What kind of function is this? Okay. Sine. And what are we using? X or theta? Theta. Okay? So my equation is y equals -3 minus 4 sine theta. That work? So did we get that?
I get -3 and just sine theta.
Okay. Got to have an amplitude in there. See, that's why I try to be consistent with writing things out over here. Okay? Calf PP. CAF, PP. Okay. All right, so we got that one down. 14, find the area of this triangle. Okay. Finding the area of a triangle is base times height divided by 2, right? So we know our base here to be 130. If I want to find the height of this, right, we're going to do this right here, correct?
Yeah.
Right, kind of similar with the bounded region question that we worked with on our assignment. So we know that we're going to have 130 times something divided by 2, okay? But we're going to do sine 39 equals h over 105. So we just need to do 105 sine 39 in order to find the height. Okay? Which comes out to what?
Sine 39.
105 sine 39. 66.08. It's fine. Okay. Didn't change it. All right, so what's 130 times 66.0 or 08 divided by 2? 4,295.11 feet squared. Is that what you got? Okay. Okay, 4,295.11 feet squared. Okay. Now this is where we're getting into that question that Miles asked earlier. Maybe. We will find out. Bad part is we're getting into the shady section of the review. It's very shady. All right. Let's see. Find the area of the segment bounded by an arc measure of 70 degrees and the chord joining it endpoints of the arc in a circle with a radius of 12 feet. Because it's 70 degrees, we know it's going to look something like this. We've got 12 there. We've got 12 there. Okay. We're looking for this shaded region. Okay. So the first thing we're going to do, let's see, we said this was 70 degrees. Okay. What's the first step in this? Area of the sector. How do I find the area of the sector, Miles? Okay, so I'm doing pi what squared? Pi 12 squared. What over 360? Okay, so pi 12 squared times 70 over 360. What did that come out to for you? Or anybody for?
Oh, what? You get 87.96.
87 point. I got 87.92, but there could be a difference between using the symbol pi and using 3.14. You got 9.6? Okay, it's not that far off. All right, so that's first step. We're going to hold on to that. What's the next thing that we need? Area of the triangle. Okay, so we need the area of the triangle. What's the base of our triangle? 12. So we need 12 times something divided by 2. And we need our height. Okay, so we're going to need that line right there with our height. Okay, how do I find that? Sine 70. Good. Yes? Yeah, because... Okay. So what do I need to type into my calculator to find height? 12 sine 70. Okay. Let's make that 11.3. Okay. 12 times 11.3 divided by 2. Okay, I got 67.66. Again, I don't know that it's going to be a big difference.
Because we're rounding, right?
Right. What's 87.92 minus 67.66? And I got 20.31. I'm not sure. But again, so long as your work is right, your estimations shouldn't throw it off by enough where I'm going to count anything wrong. Okay? All right, and that should be in feet squared. Okay? You understand what we're doing there? All right. 16. The latitude of the U.S. military academy is 44 degrees north of the equator if the diameter of the Earth is 7,920 miles. How far is the U.S. military academy from the equator? What do we do to do this? How far? This is arc length. Arc length. All right. Does anybody remember what the arc length formula is? Okay, so we got 2 pi. The radius that we want, we're going to end up taking 7,920 divided by 2. What is that?
7,000.
3,960. Okay, and we want 44. So 2 times pi times 3,960 times 44 divided by 360.
2,041.06.
Actually. Oh, 6. Okay. And that should be in miles. It's really confusing when you have somebody in class whose name is Miles, like using his name as a unit.
But I've never said that.
How many miles is it from the equator to the U.S. military academy? Like, well, shouldn't we factor in how tall Miles is?
I've always thought about that.
I can tell you right now, I'm not 5,280.
Would be impressive. All right.
I have questions.
Factor x squared plus 2x plus 9 over the set of complex numbers. Okay. So, yeah, this is going to end up being with the quadratic. So, over a set of complex numbers. So, essentially what we're going to end up doing here is doing -2 plus or minus the square root of 2 squared minus, yeah, because it's complex. Yeah, so we have to. 4 times 1 times 9 over 2 times 1. We got 2 plus or minus. I hope this shows up on the video. I don't know. I'm blue on like dark, whatever. 2 squared is 4, so we got square root of 4 minus 36. So it would be what, -32 over 2. Okay. So you can end up taking that I out. So we're going to figure out 32, 2, and 16, 2 and 8, 2 and 4, 2 and 2. So we need basically 4 radical 2. So we're getting 2 plus or minus 4i radical 2 divided by 2. Okay, and again, just to throw work everywhere so it's impossible to tell what's going on, that's going to be 1 plus or minus 2i radical 2.
Should it be -1?
It should be -1. Well, oh, because I forgot it all the way through here, didn't I? Okay. Yeah, should be -1. Which means when we go to plug it in here, what they're looking for is x plus 1 minus 2I radical 2, x plus 1 plus 2I radical 2. Those are the solutions that it's looking for. Okay, so it's looking for this right there. Okay, will I accept this? Probably. But if my teacher said probably, I would probably work really hard to make sure that I got the answer that I knew was going to guarantee it correct.
If you would have said that, we'll see if I'll counter. Then,
Yeah.
Then.
Yeah. We'll see.
We'll see.
Okay. What do you mean? All right. 18. I think at this point I'm probably going to have to take 18 and move off to another page to be able to work this out. All right. Can somebody give me the, actually I've got it right here. 3 secant 2 theta minus 2 radical 3 equals 0. Hopefully we're getting a lot better at this. What's my first step in this?
Remove the 2 radical 3.
Okay, so I got 3 secant 2 theta equals 2 radical 3, right? Because we added that to the other side. Then what did we want to do? Divide by 3. I got secant 2 theta equals 2 radical 3 over 3. Now, I believe this is one of those scenarios, because obviously we don't have a special right triangle that uses 2 radical 3 and 3. So if you consider this, this has been where it's had a radical in the denominator. So let's see if this is actually equal to the same thing. Is 2 over radical 3 the same as 2 radical 3 over 3? Yes. All right, so what we're saying is that secant 2 theta equals this, right? And that's sometimes hard to see, okay? All right, let's come over here, find out where that happens at. Secant is reciprocal to what? Cosine. All right, so what we're seeing there is hypotenuse over adjacent. So we should wind up with something like this, where I've got 2 and what, radical 3 down here and 1. So my degrees there are 30. Is that the only place where I'm going to get that, though? All right, should also get it down here, correct? So this is 30. This should be 330, correct? All right, make sure. All right, and 2 theta. And trying to figure out if there's a positive or negative involved in this. So we'll at least figure this much of it out. So 2 theta is going to be 30 and 330, right? So theta is going to be 15, right? And what else? 165. Okay, so it looks like we have the potential to go around again, which is going to be 390. What's 390 divided by 2? Okay, 195. Okay, we're still quite a little ways out from this. Let's do 330 plus 360.
330 plus 360?
Well, we're at 330, so we're going to go around again. 690. What's 690 divided by 2?
345.
345, which keeps me under, but we know we can't go over that, so our answer is 15, 165, 195, and 345. Question? Got it? Good. All right. 19. 2 sine theta over 3. That's a good sign because it means we're probably not going to have that many answers because we're going to end up having to multiply. Radical 2 equals 0. Okay. What do I do first? Add radical 2. So we got 2 sine theta over 3 equals radical 2. What am I going to do here? Divide by 2. Sine theta over 3 equals radical 2 over 2. Okay, opposite over hypotenuse. Does this look like something that we can work with? Okay, are you sure? Right, so what we are saying is that this is a rationalized denominator, correct? That is equal to 1 over radical 2. Yes? Okay? Because we don't have an opposite that's radical 2, right? Especially with a sign. So, okay, we get this guy here. Opposite, positive radical 2. Okay? Hypotenuse, let's see, did I get that wrong? Opposite? Oh, 1. All right, let me get this set up right. First, 1, radical 2. All right, which means what is my angle here? 45. Okay? All right. But I can get another one over here, correct? Okay. Which means this one's going to show up at what, 135? Okay. So if theta over 2 equals 45 degrees, then what is theta?
I have a question.
Did I mess something up?
How did you go from being dividing by 3 to dividing by 2?
Oh, yeah, that's a good point. Because sometimes my brain just goes on autopilot and just starts doing its own thing. 3, 3. So what's 45 times 3? 135. And if you take 135 and multiply it by 3, you're going to be over 360. So 135 is the only one that's going to work. Correct? All right, we're down to question number 20. Boom. Find the equation of line equidistance from the point 7, 1, -1, -5. Write the equation in double intercept form. So how many of you did this as a perpendicular bisector? Okay. What was your answer?
Y equals -4/3 x minus 6.
Ooh, wrong. What'd you get?
-1/2 x plus 7.211.
Also wrong. Anybody else get an answer? How many of you did it the old-fashioned way? All right, Fanny, what'd you get?
-4/3 x plus 2.
That is correct. Maybe we ought to do it the old-fashioned way. Okay? Either that or do better at doing the perpendicular bisector. I'm not sure. Okay, so we're going to do, let's see, we've got 7 and 1, so let's do x minus 7 squared plus y minus 1 squared. Okay, on the other side, we're going to do x plus 1 squared plus y plus 5 squared. All right, x minus 7 squared. It's x squared minus 14x plus 49 plus y squared minus 2y plus 1 equals x squared plus 2x plus 1 plus y squared plus 10y plus 25. Okay? Any struggles with that so far? No? We're good? Fanny, correct me if I mess up here somewhere. We've got x squared, y squared, so we'll cancel out on both of those. We're going to move everything on the left-hand side that is an x or a constant to the right-hand side. We're going to move anything that on the right-hand side that's a y to the left-hand side. All right, so I've got a 49 and a 1, which means I can subtract 50 to the other side. Okay, I've got a 14x, which means I can add that over here. Okay, let's pick a different color. Let's subtract 10y over here. So negative 2y minus 10y should be negative 12y. Let's see, that's going to be 16x. And we've got 25 minus 50, which is going to be negative 25. We're going to divide all that by negative 12. Did I mess up somewhere? Looks like oh, okay. Because this is 26. 26 minus 50 should be negative 24. I lost this 1 there. Okay. All right, that's going to leave me with y equals negative 4/3 x plus 2.
Works for the perpendicular bisector. Wrong. I
Okay.
accidentally added the 2 instead of subtracting.
I figured it would still work. I didn't doubt that it does work. I just, if we're not going to, if doing it the old-fashioned way worked for somebody and 2 people tried perpendicular bisector and got 2 wrong answers that weren't the same, then I was going to go back to this. All right, does that make sense? Okay. All right, at that point, that's the end of my necessary need to record anything else on this, unless there are any other questions. And